Hey guys, it's Miss Diegues. Today I want to go over the area of the rhombuses. So I want to go over kind of where it comes from, and I want to go over how to use it. So if we notice here, I have the area for you, which says to multiply both of the diagonals and then divide by 2. So over here I have the diagonal BD is 6, and then I have AC. Okay, so I know that this is 6, and I know by the properties that both of the diagonals bisect perpendicularly, meaning that if this is 6, it's going to be cut into 3 and 3, so half, and then this is going to make a right triangle there. And so by that, I was able to figure out that this other diagonal, half of it was going to be 4, because we know that this is a right triangle, so meaning that I can use the Pythagorean theorem, and I can say, hey, 3, 4, 5 is that special Pythagorean triple that we use all the time. So I want to explain to you why the area of the rhombus is so similar to the formula for the area of a triangle. So notice how on both of these at the top, we're just multiplying two things and then dividing by 2. Okay, so if we look at the rhombus like this, okay, I went ahead and I erased part of the diagonal. We get a triangle here, right? So this is an isosceles triangle. And we actually, if we look at this one over here, this is also an isosceles triangle. And both of them are sharing BD. So both of these are going to be congruent, meaning that they should have the same area as well. Okay, so then if I notice here on the diagonal 1 and the base, right, I can say, hey, I'm doing diagonal 1 times diagonal 2. That should be the same as base 1 times height, right? So I'm going to say base is 6, right? And so I'm going to say the height of the triangle is 4. Okay, so then to get the area of this triangle, I would say 6 times 4. Now I want to get the area of the rhombus. So the rhombus is not just 4 for this, right? The rhombus is 8 for AC. Okay, that rhombus measures 8 from A to C. Now notice that 8 is twice as much, which makes sense. Why? Because we have how many triangles here? We have 2 equal triangles, right? So then that's why the area for the rhombus and the area for the triangle are going to be very alike. So I'm going to move on to an example so we get to practice. And so down here I have find the area of the rhombus. So the first thing that I notice is that this is 8, which means that if I add my other diagonal, it's going to slice that in half, so 4 and 4. Now I'm going to say I've got to figure out this other diagonal, whatever this other diagonal is, and I know this is going to make a right triangle there, meaning that I can use a squared plus b squared equals c squared. So it is very important that we remember that c squared is the longest leg, which in this case is going to be 10, okay, because it's across from the 90-degree angle. So I'm gonna fill in what I know. I know a is 4 squared, b, I don't know what that is, but I do know that the hypotenuse is 10. So working it out, 4 squared, 10 squared, 16 and 100. We want to subtract the 16 over to this side, and we get that b squared is 84. We want to get rid of the squared, so we square root both sides, and that gives us 9.2. So now what that means is that this little half is 9.2. Okay, so if this is 9.2, the other half is also 9.2. All right, so that was the first step. Now I'm being asked to find the area, so I still have to do that. Now the second part is finding the area, because I already have diagonal 1 and diagonal 2. So then I'm gonna plug in or substitute what I know. I know this is 9.2 6.2 and 9.2, which creates 18.4. And I know this is 4 and this is 4, which make 8. So times 8, and then divide that by 2. And so when I put that in the computer or in the calculator, it gave me 73.6 inches squared.